Hey guys, how are you doing? Today we're gonna do something pretty cool in math, and that is how can we make a line touch a parabola at one single point. You know that when you have a parabola, let's do this real quick. When you have a parabola, you're always gonna have something like this. You're gonna have, if you have x squared, it's gonna be something like this. The only way in which, well, if you have a line, first of all, even if it's a line that, well, I don't know, it goes something like this line should, most of the times, always, touch the parabola at 2 points, okay? It's very easy for the line to touch any parabola at 2 points. We could also have a line that goes like this, you know. This line would also touch the parabola at 2 points. We need to find a way in which we only touch one point of the parabola. And how can we do that? Well, there is something pretty useful that we can exploit about these types of graphs, and that is the vertex. The only way in which we can make a parabola have one point or one solution with a line is going to be this one. We have this vertex. If we can create a line that is tangent to this vertex, then we have a line that has one solution to with the parabola, okay? And how can we do that algebraically? Well, that's pretty simple. First of all, we could try to define any function, any parabola. We're gonna find f of x is gonna be equal to this one would be x squared plus, well, whatever, 3x plus 4, okay? If this is the parabola that we have, how can we make a line or find the equation of a line that only touches this parabola at one point? Well, let's see that. So basically, we know the line would have a slope of 0, okay? A slope of equals 0. Because we know there is no change in y. Okay, change in y is equal to 0. Therefore, we would have a change in x, but nothing happens in y, so that's going to be 0. Now, if we use the slope point formula, then we have the following. We know it's going to be y minus y1 is going to be equal to the slope m times x minus x1. Okay? We know m is equal to 0. So you have y minus y1 is equal to 0, meaning y, the equation of the line that we want, is going to be equal to y1. Okay? Now we just need what is this y1 in this case? Y1 is going to be the y coordinate of the vertex, okay? We need to find the height, or how many units we shifted this parabola up or down. And how can we do that? Well, we need to evaluate the function at if we say that the vertex has these coordinates, the vertex is going to be hk, then y1 is going to be equal to k, which is the same as the function evaluated at h, okay? Now let's try evaluating the function at h, but first we need to find h, of course, so let's do that. Now we know h is going to be minus b over 2a. If we have this function, you know, an arbitrarily chosen function, minus b is going to be minus 3 over 2a, 2, okay? This is the coordinates of the x coordinate of the vertex for this parabola. Now, if we evaluate the function at that x value, then we have that f of minus 3 over 2 is going to be equal to minus 3 over 2 squared plus 3 times minus 3 over 2 plus, I'm gonna, you know, we're playing with denominators of 2, so I'm gonna write right away actually, although this one, yeah, never mind, this is just gonna be 8 over 2, okay? Now this is the same as if we did, this is gonna be 9 over 4, this is gonna be minus 9 over 2, so we have 9 over 4 minus 9 over 2 plus 8 over 2. This is going to be 9 over 4 minus, we get minus 1 over 2, which is the same as if we had minus 2 over 4. and this is 7 over 4, okay? Now this 7 over 4, I'm going to continue down here. 7 over 4 is equal to k, okay? And we keep going with blue. 7 over 4 is equal to k. And now we know that k is the number that we're looking for the equation of our line. And that's going to be pretty simple. So the line that we're looking for is going to be y is equal to 7 over 4, okay? That's pretty nice.